What is up, guys? We're going to be taking a look at this lab, CSRF with broken referrer validation. The idea is that there is some cross-site request forgery protection in the form of a referrer header. So the endpoint we're posting to is going to look at the referrer header and use that to validate the authenticity of the request. But as we can see in the title, the referrer validation is going to be broken. So let's start by exploring the legitimate functionality. We've signed in with the provided credentials. Wiener, Peter, we're at the change email functionality, and we're going to update our email with new email at newemail.net. And we're going to harvest the request in the background with Burp Suite. So if we take a look at the post request that was dispatched to the /change email endpoint, we can see that the browser is including the referrer header to indicate where that request came from. Now, this is relevant in the context of a cross-site request forgery attack, because if this post request originates from the attacker controlled domain, well, obviously the referrer header is going to be the attacker's domain rather than websecurityacademy.net. And what we find here is if we were to subtly alter the domain, so here's a request in burp repeater, we'll just add a second Y at the end of academy. Let's send that to the back end. All of a sudden we get a 400 bad request. Notice the response body, invalid referrer header. Now, it turns out that we can change any of the other information. For example, we could change the ID. It's not a problem. The only thing it's really validating here is the domain on the referrer header, so websecurityacademy.net. Now, the key to the attack is it doesn't necessarily care where the domain appears in the referrer header. It just needs it to appear there. In fact, it needs everything, including the lab ID up to websecurityacademy.net. But imagine we were instead coming from evilhacker.net and we had this domain as a query string. Let's see what happens if we dispatch that request. All of a sudden, we don't get the invalid referrer header, because the endpoint is looking for the presence of that domain, including the lab ID. It's there. It's just not properly validating that this is part of the query string. This is not actually the domain. The origin is evilhacker.net. This domain is just tagged on as part of a query string. So imagine now our origin is the attacker-controlled domain. We just ensure that a query string is sent along with the post request when the victim lands on the attacker-controlled domain. So you can begin to see how this conceptually would work. We're going to start crafting this attack on the exploit server. There is an additional hurdle that we're going to have to jump over, and that's usually when we send these cross-domain requests, it's not going to include the query string as part of the referrer header, because sometimes the query string could contain sensitive information. So when the browser attaches the referrer header, it's just going to be attaching evilhacker.net. So as part of our attack vector, we're going to have to ensure that the browser also tags on the query string to the referrer header. Now, when we look at the solution, it doesn't actually give us the payload. It just directs us to a second lab, CSRF vulnerability with no defenses. So the quickest way, if you don't want to type out the entire payload, is to head to that lab, CSRF vulnerability with no defenses. Let's have a look at the solution here. Just grab this HTML snippet because we're going to be using that as our payload. So here we are at the exploit server. We can copy and paste that payload. Now, we do need to replace the lab ID as usual for these types of labs. So I've pasted in my lab ID. Remember, it's going to be unique to your session, so you can't just use this lab ID. And also this URL encoded @%40 is fundamentally broken as part of this payload. So we're just going to replace that with the regular @. Now, let's return to the concept of this. We need a query string in the victim's browser. We don't just want them to be at evilhacker.net. We want them to be at evilhacker.net query string. And then the query string should actually be the domain of the valid referrer that the endpoint's going to accept. So the question is, how can we set up that query string in the victim's browser? And the answer is we can make use of JavaScript history.pushState. It's going to accept 3 arguments. The middle one is always blank. It's just there for legacy reasons. We don't care about the first one for the purposes of this attack. In fact, we only care about that third parameter. Now, the easy explanation of history.pushState is it's a little bit like changing the location of the victim's browser, but it doesn't trigger a page refresh. So in fact, all it does is just change the value in the victim's URL bar and add an entry to the browser history, but it doesn't actually change the location on the page. So the victim stays at the same place, it's just that their URL bar now has this query string appended. And also we need to make sure that where it says your lab ID, I'm going to paste our lab ID. Now we're most of the way there, but not quite. If we were to store this and view the exploit, if you were staring fixedly at the browser bar, you may have noticed that history.pushState get called. We had the query string appended, but the problem is we still get this invalid referrer header. And the reason is browser security. The browser is not going to send that query string cross-domain because it could contain that sensitive information. So we also need to convince the browser that it's okay and that the browser should send that query string along with the rest of the referrer header. Now that's not actually too difficult in this case because remember this is the attacker controlled domain. So it's fairly straightforward to send arbitrary headers. Referrer policy unsafe URL. And this means that it's going to be okay for the browser to set the entire URL including the query string as part of that referrer header when it posts to the change email endpoint. By the way, just a side note here. Notice that the referrer policy header is spelled correctly with 2 R's, whereas the referrer header, again for legacy reasons, has a single R and is technically misspelled. Now we just need to make sure there's no space between the content type and the referrer policy headers. We can view the exploit, again as ourselves, not as the victim, and you can see in this case, our email has been successfully changed. So if we take a look at the post request in Burp Proxy, take a look at that referrer header. So it has the exploit domain, so the equivalent of evilhacker.net. That's not the right domain, but then it has the query string and it has the correct domain that's expected by the endpoint. So you can see why this referrer validation is broken. This is not technically from the right domain. The endpoint's supposed to refuse this request because it fails referrer validation, but it's not doing that. The validation is broken. The endpoint can simply see that it has the correct domain as part of the query string, and it's validating and processing that request. Okay, so we have absolutely everything in place. The only final thing to do here is to make sure we change the value of the email since we've already assigned Wiener's email to anything at websecurityacademy.net. For the victim, we need to set up a new email address, otherwise it will fail because it can't assign an email address if a user already has that email. So let's store this with the slightly changed email address, and I'll choose deliver exploit to victim, and we get the flag, congratulations, you solved the lab. Simple mitigation here, use a cross-site request forgery token. That's the whole point. It's always going to be the key way of protecting against cross-site request forgery attacks. And you can see in this case, although we have a session token, we do not have a cross-site request forgery token. So although there is some protection in place in the form of referrer validation, that could be fine in addition to the CSRF token. But the reality is the CSRF token is going to be the primary way of protecting against cross-site request forgery attacks. All right, that's pretty much it for this lab. Thanks for checking out the content, and I'll catch you guys in the next lab.